Well, good evening, everybody of the IEEE Communications Society. I'm glad that everybody here came. Well, tonight I am Richard Fenster, and I'll be explaining how the internet works. So the internet, it's kind of a vital resource. The internet, we call it by many different things like cyberspace, but it's been known as ARPANET, World Wide Web, the information superhighway. But what really is the internet? Is the internet the thing that we pay people, like the companies like Verizon, AT&T, Unet, Global Crossing, Level 3? Is that what is the internet? Or is it the different hardware protocols that we actually use that make up the internet, like NICs, firewalls, routers, Ethernet, TCP/IP? Or is it the different protocols that we actually interact that get data done? What actually makes up the internet? What makes up this World Wide Web, this information that goes between humans, between countries, between governments? What makes up the internet? So tonight, I am going to explain to you what makes up this thing we call the internet. So this is a photo of the internet. You can't tell because the resolution on the projector is so bad. But a very vital resource on the internet defines the internet as a global interconnected computer network that uses a standard protocol suite. And it serves billions of users using these networks. And furthermore, it actually goes and says that it's a network of networks, that private, public, academic, business all come together to build this computer network, to build this information hub that we use today. So to actually understand where the internet comes from, we got to take a quick time travel back to the 1960s. And to explain this, I have a movie clip that actually explains this pretty well for it being in its time.
Stop, don't come back.
Lights, camera, action! Mike! Where are you?
He's up there, in a million pieces.
Mike! Are you there?
Don't get shouting here, watch the screen.
Mike!
Why is he taking so long?
A million pieces take a long time to put together.
Oh, where are they?
There's definitely something coming through.
Is it Mike?
Well, it's hard to tell, but I...
Oh!
So anybody know the technology that's being described there? It's something very fundamental. The telephone network, I'll give you a hint. The telephone network is circuit switched, while the data network is
Packet switch.
bingo, packet switched. And this guy here came up with the idea in 1961. Instead of actually switching relays together and making a connection so you can make a phone call, he had the idea of let's break up the data and then send it as little bits of data across a common medium. So the network will actually store and then forward the results on to the next interconnect of the network. And this idea from 1961 was actually implemented in a variety of networks in the 1960s, but one of the more famous one was ARPANET. And this was actually a phone conversation of when they were first testing it. And the system crashed on the third letter, but it proved the concept could work and actually be useful in the real world. So you got ARPANET in 1969. The UK people tried to create their own. You had the one out in Europe, MeritNet network. And all these little innovations came up with the idea of TCP/IP. And that's when we entered the 1970s, the disco era. But anyway, so what is TCP/IP and what is the major innovation that happened? So TCP basically takes the fault out of the network. So before then, the network had to be 100% reliable. And now with TCP, the network could break in the middle because like a plane could fly through the satellite signal, or a bee decided to take a shit on the antenna and you lost some data. But what TCP does is it allows the host to actually take care of these errors in the protocol and errors in receiving data and reverse engineer and figure out what went wrong and what needs to get resent. So the basic animation for this is we have a bunch of data. It can route to the individual host and actually make it in one piece eventually to its final destination. And the IP side of it, which we call IPv4, is the routing side of it. So how do you actually get data from point A to point B when you have point C, D, and E? And what IP addresses allow you to do is actually route that data based on a set of rules and whatnot. And we'll get into how that actually works later on. So finally, one of the last major innovations that happened in the 1970s and 1980s was a physical link protocol that really did innovate and make networking a lot easier. So there's frankly a very, very awesome, handsome looking man, and I would say great innovator. And something that many people don't know is now he's a Longhorn. But Bob Metcalfe, inventor of the Ethernet, in the 1970s, he came up with a concept of a physical link protocol that computers can talk to each other. And 3Com decided to use TCP/IP over the other packet switch protocols out there. And that there basically allowed TCP/IP to become keen and become the basis of the internet today. So by the 90s, you had an international network of computers on this TCP/IP packet switch network. And this is the National Science Foundation's network that had a grand total of 25 megabits back in 92. Now it's probably terabits, but technology evolves. So this is when we entered the 90s. In the 90s, something amazing happened. You started having the public actually enter the World Wide Web. So in 91, CERN, which is the research center up in Europe, there was a British scientist, Tim Burns, who came up with HTML. And what HTML is a markup language so you can access pages, and that's where this knowledge is stored on the internet. And by 93, you had Mosaic, which was the first internet browser. And this would interpret that HTML into text that we can actually see and use. And all these little innovations kept leading up to 95 when AOL actually launched AOL.com. So now the general populace is not just tech geeks, could access the internet and access mail, news, chat, and all this other variety of resources that the internet has to have. And this is where the internet really began. This is the...
What is it?
This, Jen, is the internet.
What?
That's right.
This is the internet. The whole internet.
Yep. I asked for a loan of it so that you could use it in your speech.
Why, thank you. Well, anyways, so the internet is really not just one thing. It's an idea. And this idea of having interconnection is what makes the internet work. But actually, how does the internet work in the real world? Let's say we have this fool here, Joe Bob, and he wants to actually make some money because he had a great idea. He wants to sell, some internet services to a bunch of people that don't have internet. And he can make a bunch of money off of it. So the way he does that is he's going to use this concept of a border gateway protocol. And this protocol basically allows this distributed nature of the internet to work the way it works today. So basically what he'll do is he would announce himself on the network. And then other routers that use this protocol will accept his announce and do other things. But there's also a political side to this whole thing, and we'll get into that here in a sec. So Joe Bob here, he wants to, get on the internet so he can make money. So he's going to approach a couple corporations, AT&T and Level 3, for instance. And Joe Bob's going to be like, yo, AT&T, how much money do I have to pay you to transfer my traffic? And AT&T's like, we're the best. So we're going to charge you $8 a megabyte of traffic across our network. And Joe Bob's like, well, shit. So he goes up to Level 3 and is like, hey, Level 3, how much is it going to cost for me to send traffic across your network? Level 3 is like, oh, we could do it for 50 cents, but we only can transfer it to Europe. So you can have all these different little caveats with different companies and whatnot. And this border gateway protocol allows this caveat process to actually work. So Joe Bob there, he's like, okay, I can agree with this. Let's make this happen. So you get some lawyers involved. You make an agreement. You create a peering contract. And you throw a lot of money around. And yeah, lots of money. The internet is a money sink. Let's just put it that way. And once you get all the money involved, you have this pairing contract between Joe Bob's ISP and AT&T. And now traffic can flow between those two networks. And also now you have another contract between Joe Bob and Level 3. And internet traffic can go. So physically, this looks like a couple racks in a data center. You got AT&T's equipment, you got Level 3's equipment, and you got Joe Bob's equipment. And now they can all interconnect. So what it'll look like is Joe Bob has a bunch of users, and those users will generate traffic, and you'll see traffic will flow from Joe Bob to Level 3 and AT&T. The thing is AT&T charges like 40 times more. So you're going to send more stuff to Level 3. So, I mean, this is cool, but how do the real big guys do it? I mean, we want to know how AT&T and Level 3 actually make this work. So, since the internet is not owned by a single government or a single entity, we have these things called internet exchange points. And what these internet exchange points are open areas where there's just racks and racks of switches owned by hundreds of different companies. And they all agree to transfer traffic for people that have traffic going to this internet exchange and back out. So this is the one up in London in the Docklands, if you've ever been there. But here's a couple here in Texas. We actually have our first one that opened up in 2013 in Austin. But we have a bunch of old ones from the 90s up in Dallas. And Dallas, since it's the corridor of many major interstates, naturally has more internet exchanges than the rest of Texas. So basically, internet exchanges are hundreds and hundreds of switches and routers that allow this border gateway protocol to actually work. So there's a popular one called 6, which is the Seattle Internet Exchange. And if you're an attendant of the Westin in Seattle, you can pay the management to actually stick a cable from your office to the patch panel down in the basement. And then from there, you are on the core of the internet. But the problem is you need to make those contracts and whatnot with the different ISPs there and different backhaul carriers to actually move your traffic. If anything, you'll just be observing the internet. You won't actually be able to use the internet. So just to review, Joe Bob is a small ISP. He peers with AT&T, Grande, Time Warner Cable, other larger ISPs. Now AT&T is a large ISP, but also it's a transit provider. So AT&T might own cable to get data from, let's say, New York to London. They actually own a physical cable. And they will go up to you in the New York Internet Exchange, be like, hey, for every megabyte of data we get from New York to London, you pay us $8. And we can get it to you there in 100 milliseconds or something like that. So that's where the money-making part of the internet is actually owning that back-end infrastructure. And that's where Level 3 makes a lot of their money, is Level 3 has one of the largest global presence. I think Cognitive might be a little bit higher than them. I'm not sure. But people pay them to get traffic from point A to point B while you're trying to get it to point C, but they'll route it the backhaul, and then you have to figure out the last mile or whatever. So there's another company called Hurricane Electric, and they've been around since the beginning of the internet. And this is actually a pairing contract. So Hurricane Electric, they don't believe in lawyers, they don't believe in all this private pairing, you have to have service level agreements. They're more of, I guess, the idea of what we think of the internet, open. So they have a couple simple rules, like if you send traffic to us, we expect you to take some of our traffic. If you cannot route traffic that we don't allow you to route through us. We'll still take it, but if you do that, you'll break the contract with us. And they have some other rules there to help push the innovation of the internet. Like If you peer with us, you have to also peer at IPv6 level rather than just IPv4 only. And since there is no global accountability of who can route to who, there's agencies out there that will look at these announced traffics. So they have probes in each of these internet exchanges. And they'll see what is the global routing table at that time. So you see back in 98, we had less than 100,000 different peers. And now we're over to 500,000. And IPv6, you can see the same thing happening as well. Except back here where we had the IPv6 day or wherever, you see there's a sharp jump. So let's do a little case study. And let's actually take UT, for instance, since UT is sort of a small ISP, like Joe Bob. So UT, their registration number is 18. They actually peer with 3 other different peers. So Texas Department of Information Resources, University of Texas Systems, and Learn. And you see majority of the traffic goes through this weird Texas Department of Information Resources. So let's go see who that peer peers with. A lot of P's. And you can see that they peer both on an IPv4 and v6 level with Quest in level 3. And then from there, if we go and look at Quest communications, you see that there's hundreds of different peers. But the thing is, this is public peers. UT might have a bunch of private contracts that we don't know about, and they route traffic through. But this is what publicly is available that shows us the peering contracts and whatnot. So this guy here, this is the top peers in the United States. You can see Cognite Communications is at top, level 3 is next, Air King Electric. If you start going through this list, you'll start seeing businesses like Netflix. So Netflix is what, 1/3 of the internet during the night is Netflix driven. So they have their own data content delivery network to help save on bandwidth costs when you're trying to peer with other people. You can see a lot of the cell phone carriers. You'll see, for instance, UT's on there, Apogee if you live in West Campus. You see that everyone is on this list, and they're somehow interconnected in this web of knowledge. So what is Border Gateway? So Cisco has a long, about 4,000 or 5,000 page manual on what Border Gateway Protocol is. So I'm going to try to explain that in 4 slides. Let's see what happens. So Border Gateway Protocol, neighbors called peers are established by manual configuration. So this is the contracts people make between routers, and they create a session. And then every 30 seconds, you try to keep this session up and working. And as long as you have a keep alive message going, internet traffic can flow through those routes. Those routes that are advertised to you by these other peers are available to you. So for instance, when Iran cut off their country from the internet, people knew well before websites went down and whatnot that they no longer were on the internet because this 30-second keep alive message stopped coming from the border routers in Iran. This is a flow chart or a state machine. There's about 600 pages on Wikipedia about what the state machine does. But basically, you go through this when you're establishing a connection, and once you're established, you constantly reconfirm that those routes and those that peer is still alive. And the cool thing, let's say level 3 goes down, there are other ways to get to London, to get to Hong Kong and whatnot.